For this next example problem, we're going to study the same location that we analyzed the always stop control module. We noticed before that this intersection is expected to operate at poor level of service in a future design year. And we want to evaluate what would happen if we replace this always stop control with a roundabout. So we're going to repeat those very same inputs, but we are going to replace this stop control with a roundabout using the simplest configuration available, which is one shared lane for each approach, left, through, and right, and one circulating lane across every single approach. With that, let's enter our roundabouts module. Let's start a new file. And here we also don't have any major street, minor street. The only input necessary for this analysis would be the peak hour factor, which is 0.92. So we don't have to change anything here. Let's get started with our geometric inputs. So as we discussed, we're going to use the simplest approach, which is going to be one approach lane in all directions, all of them shared left, through, and right. We also have just one circulating lane conflicting every single approach. And then we can proceed to our traffic inputs. So let's repeat those same movements that we have modeled before. We're assuming no U-turns for this future condition. So eastbound left, I have 39, 5, and 484. Westbound, I have 5, 45, and 140. Northbound, I have 289, 423, and 5. And finally, southbound, I have 5 left, 471 through, and 24 right. We have 0 trucks on eastbound, westbound approaches. And for northbound and southbound, we have 2% for every single movement. We have a passenger car equivalent, which is used to model the effects of trucks. Default value is 2, but if you want to change this in your model, you are able to do that. You are able to enter pedestrian volumes. And if you want to calibrate your driver behavior, you can also change the critical headway and follow-up headways, which is based on the same concepts and principles that we discussed under two-way stop control. Again, we have our input for the bumper-to-bumper distance for passenger car and heavy vehicles in a queue that we use internally to compute my queue lengths. And with that, we are done with our modeling. We can go to our report. And then we can see what we should expect if we replace that always stop control with a roundabout. Again, we have a sketch of my roundabout, a summary of my inputs, my critical and follow-up headways that were entered. And we can see that overall, our roundabout is performing much better. So now I'm operating overall at a level of service B with an average delay of 13 seconds per vehicle. I have no approaches that are failing, so no level of service F. So everything's around B and C. So in terms of operational performance, we can say that a roundabout is a clear winner compared to the always stop control intersection. And these are the kind of analysis and studies that we can do using our HCM approaches and based on the what's implemented in the highway capacity software. And with that, we're done with this example problem.